Welcome to the Explainer. If you work with data in Python, you already know Pandas is an absolute necessity. But today, we're taking the foundational documentation and transforming what might look like dry code into your ultimate superpower for taming chaotic data. We are going to walk through the core mechanics step by step and show you exactly how to build a flawless, logical data assembly line.
Here is the agenda for our assembly line today. We'll cover 1. Core data structures. 2. Navigating and selecting data. 3. Cleaning and transforming data. 4. Grouping, merging, and reshaping. 5. Time series and categoricals. And finally, 6. Plotting and exporting. Let's dive right in.
Section 1. Core data structures. Building the containers. This is our very first stop, where we actually construct what's going to hold our data.
Okay, so think of a series as just a single column of information. It's a one-dimensional labeled array, and it can hold pretty much anything. Integers, strings, Python objects, you name it. But when you snap multiple series together side by side, that's when you get the data frame. A data frame is essentially your supercharged two-dimensional data structure. It acts exactly like a programmable spreadsheet with rows and columns, but it has the sheer power to effortlessly handle different data types in every single column. This is the absolute core engine of your workflow. It's what allows you to manipulate millions of records in one swoop.
Section 2. Navigating and selecting data. Looking inside. Now that we've got our containers, how do we peek inside and grab exactly what we want?
When you're dealing with massive data sets, you obviously need ways to quickly figure out what you're even looking at. To get a quick pulse on things without scrolling into infinity, you can just use the head and tail functions to peek at the top or bottom rows. Need to drop down a level closer to the metal? Well, NumPy instantly returns a standard NumPy representation. Though, keep in mind, since NumPy strictly requires a single data type for the whole array, Pandas is going to have to find one type that accommodates all your columns. And if you need immediate mathematical context, just call describe. It generates a statistical summary of your numerical data literally in an instant.
Now, here is a classic stumbling block for so many people: understanding the difference between label-based and position-based selection. It really just comes down to this. You use lock when you know the explicit label. You know, the exact explicit name of your row or column. But you switch over to ilock when you need the strictly numerical integer position. Kind of like how standard Python lists work under the hood. So just remember, L for label and I for integer. Seriously, keeping that straight will save you hours of debugging, and using these optimized methods is highly recommended over standard Python brackets.
You can also use Boolean indexing to instantly filter thousands of rows down to only the ones where a specific condition is mathematically true. For example, if you pass the condition df.a more than 0 right into your brackets, Pandas automatically filters out any rows where column A is 0 or negative. It is an incredibly fast, dynamic way to isolate the exact subsets of data you care about, and it leaves slow, traditional Python loops completely in the dust.
Section 3. Cleaning and transforming data. Fixing the mess. Because, let's be real, in the real world, data is full of holes and errors.
The absolute biggest monster in data analysis is np.nan. This is the default marker in both Pandas and NumPy that represents missing or empty data. Now, by default, it conveniently gets excluded from your mathematical computations, but if you don't handle it properly, it's that dreaded empty void that can throw a massive wrench into your assembly line and totally skew your final results.
Luckily, you've got 3 primary weapons when facing this monster. First up, you can use drop in A to just ruthlessly discard any rows that are missing pieces. Just toss them out. Second, you can use fill in A to step in and patch those holes yourself with a specified default value. And third, if you just want to map out where these monsters are hiding, isInA creates a neat little Boolean mask locating exactly where those NaN values are sitting.
Once everything is clean, we can start rapidly transforming things. You can apply statistical operations like mean to calculate averages across rows or columns, or use ags to apply your very own custom-defined functions. Dealing with messy text, Pandas equips you with vectorized string methods via the strat attribute. This means you can quickly standardize, lowercase, or split text across millions of rows all at once without writing a single, painful for loop.
Section 4. Grouping, merging, and reshaping. Molding the data. Now it's time to take our pristine data and combine it into its final shape.
Okay, pay attention to this, because when combining data sets, there is a massive performance note you need to keep in mind. Adding rows to a data frame iteratively, one by one, is incredibly slow. It's super expensive because Pandas has to constantly reallocate memory for the whole table. Actually, scratch that. Just never do it. Instead, you should always pass pre-built lists to your constructor or use concat to stitch massive tables together all at once. And if you need relational database capabilities, merge enables full SQL-style joins to align your data perfectly on unique keys.
The GroupBy operation is pure analytical magic. It operates on a really strict rhythm: split, apply, and combine. First, you split the dataset into groups based on some criteria, like grouping your sales by region. Second, you apply your calculation, maybe a sum or an average, to each of those groups independently. And finally, it effortlessly combines all those independent results back into a brand new, highly readable structure.
What if your combined data is just facing the wrong way? Well, Pandas offers some incredible reshaping tools for that. The stack method compresses a level on your columns, essentially pivoting them straight down into the index. Or, if you need a total overhaul, you can use pivot_table to effortlessly reorganize your dimensions from scratch. You specify exactly what you want as your values, your rows, and your columns, and boom, you get the exact view you need. Section 5. Time Series and Categoricals. Specialized Handling. This is crucial because some data operates under entirely different mathematical rules.
For financial or chronological data, Pandas acts like a master clock. It gives you the power to easily perform resampling operations, like, say, converting raw secondly data directly into clean 5-minute intervals. It also lets you make your data time zone aware with TZ Localize, effortlessly jump between global time zones using TZ Convert, and even calculate accurate dates by adding non-fixed custom durations like a standard business day. Categorical data is just as game-changing. By converting raw repetitive text into a specialized categorical data type, you save a massive amount of memory. But more importantly, you unlock the ability to sort by a logical order. So instead of being strictly bound by A to Z alphabetical sorting, you can sort by concepts like low, medium, high. It ensures your tables actually make human sense.
Section 6. Plotting and Exporting. Sharing the results. We have reached the very end of the assembly line, where we finally visualize and ship our product out into the world.
You can actually call the plot method directly on your data frames or series to instantly generate visual insights. And what's really cool is that underneath the hood of that simple command, Pandas is actually using the standard Matplotlib API to do all the heavy graphical lifting for you. It's a totally seamless integration that turns your tables into compelling visual narratives with just a few keystrokes.
Finally, it's time to ship your masterpiece. Pandas supports a huge variety of I/O tools. You can export to a standard comma-separated file using 2CSV, drop it right into a classic spreadsheet using 2Excel, or, if you want maximum performance for massive datasets, write it to a highly compressed Parquet file using 2Parquet. And, of course, the corresponding read functions let you pull all of those formats right back into your assembly line whenever you need them.
So, you've built your core containers, you've navigated the logic of selection, defeated the missing data monsters, molded your structures with merges, and finally exported the polished product. You have officially mastered the core Pandas assembly line. So, armed with this incredible capability, what dataset are you going to conquer first?